Hi everybody and welcome. In today's video we're going to talk about transforming functions. So the goal after watching today's video will be able to take a look at a function that's presented to you and basically step by step describe, is it shifting left, right, up, or down? Is it getting skinnier? Is it getting wider? And all of the related shifts that can possibly come up. So the first thing, transformation. What is a transformation? This is just the process of manipulating a function in the coordinate system. So what we're going to see as we work through this today is on the coordinate plane, we'll start off with a base function, something like this. And what we're going to be doing is we are either going to be maybe making it more skinny, maybe moving it down, but keeping everything else about it the same. Might even move it to the left or to the right. So things like this are basically our focus for today, is all the different ways that we can move around a function using some different manipulative techniques. So the first thing that we're going to talk about is a vertical transformation. So our technical definition for vertical transformation is y equals f of x. So f of x is just our original function, and what we're going to do is we're just going to add something to the original function. So this plus k is what makes it a vertical transformation. So what this is going to do is it's going to shift up or down by k. So if k is positive, we're going to go up. And if we see that k is negative, it'll be the opposite. We're going to go down. So for example, let's say we're just looking at the graph of x squared, which looks something like this, and we add 2. So if we add 2 outside of the x, what this is going to do is it's going to take everything and just move it up by 2. So we've taken our original function, and it's gone up by 2. A different type of transformation that we can also see is called a horizontal transformation. In this one, we still have f of x, except we're going to subtract h from inside the parentheses. So the key difference here is 1 we're subtracting, and 2 it is inside of our parentheses. And what this is going to do is it's going to shift it right or left. It's not going to change how wide it is. It's going to look exactly the same. We're just going to be shifting it left or right. So in this situation, what we're going to see is actually the opposite of what you would expect. If we see something like, let's say, x plus 2 squared, we have plus 2, but this is actually going to move us to the left by 2. And secondly, if we had something like y is x minus 3 squared, this is going to move us to the right by 3. And it has everything to do with the sign. So negative signs inside of our parentheses move us right. Positive signs inside of our parentheses move us to the left. And that's the whole reason why it's negative h here, is it's the opposite. That's just what I was telling you. It's the opposite of what you see. So if you see a plus 2, so like down here you see a plus 2, it's actually the opposite of that. It's a minus 2, so that's why we move left by 2, because it's a minus 2 in that case. So h in this case is minus 2. Same thing with the next one. In this case, h is actually positive 3, so that's why we move to the right by 3. So if we are to take a look at our graphs here, what we're going to see is some values that are going to occur as we are graphing. So that is our original parent function in green here. So just this x squared is in green. And then what happens is we add 6 to it. So when we add 6 to it, what we do is we literally take everything we just graphed and we move it up by exactly 6. So that's what the graph of a square root looks like. And then in red, that's what the graph of a square root looks like when it's moved up by 6 units. We'll do a similar thing here for our second one. and I'm going to ask you to actually tell me what type of transformation is happening to our f of x function right here. So you can go ahead and tell me that now. Okay, so we're going to start off with our original function, which is the absolute value of x. So the absolute value of x in green, that's one that looks like a V. I've always really liked these ones. And then what happens is we have that -2, but the -2 is happening inside of our parentheses. So -2, do the opposite of what you think, so move 2 to the right. And then from there, everything is just shifted by 2 to the right. So the V still appears, everything is the same. We've just simply gone 2 to the right. All right, so that is our first type of transformation, is horizontal and vertical. We're going to move on to our next set here, which we call dilations. So dilation is, think about it like you're inflating a balloon or deflating a balloon. You either make the balloon really, really wide, or you can make your balloon, when you deflate it, become skinnier. It's kind of more deflated. So a vertical dilation, we define this as y equals f of x. And then now, in front of f of x, we put something called a. And a is being multiplied by f of x. So this is called a compression. And it is specifically a vertical compression. So if you have, let's go back to our original parabola, something like this, y equals x squared, and then you take your y equals x squared, and out front of your x squared, you multiply it by something like, I don't know, 3. What that's going to do is it's going to take this, and by a factor of 3, it's going to make it skinnier. So this one, it doesn't move it up, down, left, or right. It quite literally just takes the exact same function at the exact same starting point and just compresses it, makes it go inward. If you have a value, let's say, I'll define this. If a is greater than 1, it's going to compress. If a is less than 1, I should set a better interval for this. So basically what's going to happen here is if we're going to see something where like a is a fraction, so like the absolute value of a is less than 1 is the best way to put that. If the absolute value of a is less than 1, then what we're going to see is it's going to get wider, so it's going to stretch. So something like, we'll do this one in green, y equals 0.5 times x squared. It's going to be a much wider, much more stretched out. A horizontal dilation is going to happen on the inside of our parentheses this time. So we have y equals f of x, and we're going to multiply it by b. So the key difference here again is that b is inside of the parentheses. Up top we had the entire function, and then we multiplied it by a. This time inside of the function, next to every single x that you find, you're going to multiply it by b. And we are going to see that it's going to stretch horizontally by a factor of 1 over b. So what this means is if we go back to our graph, and we start off with our y equals x squared, and this time, when we are drawing this out, if we have y equals 2x, but the 2x is inside of the parentheses, we're going to identify our b as whatever number is in front of x. So b is 2. So we're going to have a horizontal stretch by a factor of 1/2. So looking at this on a graph, a horizontal stretch means that it becomes wider. So if we had a factor of like 2, if we had a b value of 2, it would go really, really, really wide. But in this case, this answer here, if 1 over b was a number greater than 1, if it was like 2, you'd see it stretch. But in this case, because our 1 over b answer stretches by a factor of 1/2, that's actually the opposite of stretching. It gets skinnier. So because your 1 over b value is less than 1, in this case it's 1 over 2, it actually becomes skinnier, pretty similar to the example above in red. So the key thing here is first you have to identify b. And then second, you have to plug into 1 over b, and then 1 over b tells you what your stretch factor is. So if your stretch factor is less than 1, it gets skinny. If your stretch factor is greater than 1, just like above, it's going to get wider. So these are going to be the things that tell us basically what's happening here. So in our first example, this 3 is outside of the x squared. So we just take our original parent function, y equals x squared. So there's our original graph of x squared. And then second, what we're going to see here is that we're multiplying it by 3. So we can say, okay, we have a vertical dilation by a equals 3. So that's going to tell us that we are going to, because of this 3 right here, everything goes in by a factor of 3. So you have a much skinnier graph here. In our second example, our square root example, our parent function is y equals the square root of x. And what we're going to see is in this case, I'll have you identify it, and I'll have you take a moment to identify this here. What is our dilation happening here? So what is our dilation? Is it A? Is it B? Is it vertical? Is it horizontal? So go ahead and identify that now. All right, so hopefully you've had a minute to take a look at that. And now what we can see is, as we're working through this, we have a horizontal dilation because this 2 is inside of our parentheses. It's next to our x here, under our square root. If it was outside of the square root, it would be different, but it's inside of our square root. So because of that, this is going to make this be a horizontal dilation. We can identify that b equals 2. So that means that we're going to have a factor of 1 over b of 1 over 2. So it gets skinnier. So it moves closer towards the y-axis. So everything that we have by this factor of basically 1 over 2 is going to be moving closer towards the y-axis. So everything just a little bit like this. Again, it's almost like it's a magnet. And what it's doing is it's taking this original function and it's just trying to pull it a little bit closer towards the axis that way. So that's all that's happening here is we're just getting a little bit closer, a little bit closer, a little bit closer, all with the goal of eventually getting back to the y-axis. So with 1 over 2, that's what we see. That's what this is going to look like here. All right, so the last type of examples that we're going to see here, and that's going to basically be the last hour definitions for today before doing some practice. So we have vertical reflections and we have horizontal reflections. So a vertical reflection happens when we have a negative value in front of our function. So this is the example where we call this the negative y example. So we have our entire function, and then the entire function becomes negative. A horizontal reflection is our negative x example. This is when we have the original function, but inside of it, all of our x's become negative. So these are the two different ways that we're going to see it. So a vertical reflection is going to go over the x-axis. And a horizontal reflection is going to reflect over our y-axis. So some examples here are if we're reflecting over the x-axis, that original parent function, y equals x squared, and then we change this so that it's our negative y example, so it's negative x squared. Well, now we just simply have flipped it upside down. And we've seen a lot of those when we have that negative x squared. With parabolas, that's when they face down. That's how we know is that negative in front of our x squared value. But in a similar way here, if we have our second example, again, using our y equals x squared, and then what we do is we say, okay, let's make just the x's negative. Well, this is going to reflect over the y-axis this time. So the y-axis is here. So anything on the right side of it goes to the left, and anything on the left side goes to the right. You might be like, Mr. Reardon, in this example, it's the same. Well, that's actually true, because if you think about it, when we square something, the negatives actually cancel. So when we are squaring a negative inside of our parentheses here, what that's actually doing is it's basically negating the negatives. So nothing is changing about this function. But technically, the reason why that's true is because when you reflect it over the y-axis, because it's symmetrical, it actually looks exactly the same. So that's the idea for our reflections here. So again, as we're kind of working towards these and working through them, as long as you have those basic definitions down, you're going to be in pretty good shape. What we're going to see here is they're going to do multiple of these at the same time, and that's where this gets a little bit more challenging. So taking a look at what we're seeing here, we can take another quick graph example of each of these, and then we'll move on from there. So our first one here, our parent function is y equals the square root of x. And then what's happening in this case is our negative comes inside of our parentheses. This is our negative x example. So we are going to reflect over the y-axis. So what that's going to make this do is our new reflection is just going to be the same thing. Again, over the y-axis. So going that way. So I'll have you tell me what happens in our next one. And you can go ahead and label which axis is it reflecting over, one, both of them, just x, just y. So label what is happening. You can go ahead and answer that now. So in this case, our parent function is the absolute value of x. And what we've done is outside, we have done a negative. So that is actually the outside negative is a reflection over the x-axis. But the main thing about this question is we've also done so on the inside. And because we've done so on the inside, this means that we have also reflected over the y-axis. So we've done both. So if we graph our parent function, our nice absolute value b, what we've done is we have should see a reflection over both axes. So first, let's do this one. So straight up and straight down this reflection. And then second, this axis, and what you're going to see again is when we reflect it over our y-axis, over the green, it doesn't change anything. It's just the same. It folds over on itself because it is already symmetrical. So we see that the red graph is what our final answer for this one looks like. All right, so finishing up here, we are going to see what happens when we basically work through these functions and see multiple transformations happen. So what you're going to see is everything that we've done so far is going to come back and basically be combined together. So we can see things like adding 1. So if you remember, if you scroll all the way back up to your notes, this would be our plus k example. That would be a shift up by 1. We can also see things happening. So on the outside of our function here, we've multiplied it by 3. So when we multiply the outside of our function by a value, this is our vertical dilation. And that is our a value. So that'd be a vertical dilation by 3. And then finally inside, we see we've subtracted 2 inside of our parentheses here next to the x. So doing that is going to be a shift. And we are going to see that's a left-right shift, and a shift in that direction. The -2 means that we're actually going to shift to the right. So a bunch of different things happening on each of these, and in class tomorrow, we're going to talk about the order of the way that they shift. But just for today, we're just really focusing on which way are we shifting, how are we shifting it, and what are the vocab definitions. So to summarize, we have our H and our Ks. Those shift us up, down, left, right. So those are our vertical and our horizontal. We have our dilation, so vertical and horizontal dilations, and this is when we multiply either the entire function by a, or we multiply just the x inside of it by b, and that's going to shift us, basically make us wider or make us skinnier and taller. And then lastly, we have our reflections. If the entire function becomes negative, then it's going to reflect over the x-axis. And if our entire, just the x value becomes negative, then we reflect over the y-axis. So a lot of definitions today. The practice questions will be pretty light because we're going to focus in the classroom tomorrow on basically reviewing all of these and making sure we have the order down. So the way that you're going to be prepared for class tomorrow is if you have really good notes, even if you're not 100% of the way there on the understanding, not a big deal. Like I said, have good notes. We'll review our definitions that we just did today in the classroom tomorrow. So as always, thanks for watching. When he's barking, he's saying it's time for the video to wrap up. So questions, as always, feel free to ask.